Hi guys, Mrs. Dan's here. So this is lesson 11, which is another review for your test. I already sent you lesson 12's answers in Remind. The do now, really just quickly that congruent sides are equal in length, congruent angles are equal in measure, and when we have similar figures, the corresponding sides of the similar figures are in proportion, while the corresponding angles are still congruent. The corresponding angles are still equal in measure. When the angles stay equal, that's what makes the shape stay the same. And the sides, we say, are in proportion because when we do similar figures, they're not the same size. They get bigger or smaller. So even more importantly for your test is A, B, C, and D. So when a figure is reflected, we get congruent figures. When it's rotated, they're congruent. And when it's translated, they're congruent. So these three types of transformations, reflections, rotations, and translations, always create congruent figures. And that's how come we call these three transformations rigid motions. The last transformation, a dilation, is not a rigid motion because a dilation creates similar figures. So number one, a sequence of transformations was applied to an equilateral triangle. That means all sides are equal. The transformations used were rotation, reflection, and translation. So those are rigid motions, which means that the shapes stay congruent. Which statement about the resulting figure is true? It must be an equilateral triangle with the same lengths as the original. That's true. It must be an equilateral triangle, but the side lengths may differ. Not true. It may be scalene. Not true, because it has to be congruent. It has to stay the same shape, whether even if I did a dilation. And then D, it may be obtuse. Not true. So it's choice A. When I'm doing these multiple choice questions, I'm going to give you my thoughts as I'm reading the question. So figure Q was a result of a sequence of transformations on figure P. So that means we're starting with figure P. Which sequence of transformations could make figure P to figure Q? So remember, when they're asking for a sequence of transformations, they're asking for more than one transformation. Because something that I notice is that if the origin was my center of rotation, I could just do a 180-degree rotation and it would land over there. But that's just one transformation. That's not a sequence. So that's why that choice isn't here. So we have to go through the choices. A reflection over the y-axis. If I reflected P over the y-axis, it would end up over here. Sorry, I'm having a hard time drawing with this pen. But that's where it would end up after a reflection. And then it says translate 3 units down. If I moved this down, this curved part is in the wrong spot. It's not going to work. So it's not choice A. But so you want to use like a pencil and maybe draw these things so that you can see where does it end up. I can easily eliminate B and C because of my statement that I said before. I know that I can rotate P 180 degrees and would land directly on top of Q. So here it's talking about 180-degree rotation, but they want me to translate it also. So now it's going to slide out of place. And here's a 180-degree rotation, but they want me to translate it also. So now it's going to slide out of place. So it can't be B or C. So it must be D, but let's see how come. So if we reflect over the x-axis, so these points stay here. This one is 1, 2, 3, go 1, 2, 3, 1, 2, 3, 1, 2, 3. And I'll do this curved section as best as I can. So that's kind of what the reflection of the x-axis looks. And then they're asking me to translate it 7 units to the right. So would that work? If I took this point and went 7 to the right, 1, 2, 3, 4, 5, 6, 7, it would land here. And then this one, 1, 2, 3, 4, 5, 6, 7. Oh, it's working. This one, 1, 2, 3, 4, 5, 6, 7. Yes. So it is choice D. I think this YouTube link doesn't work anymore. Number 3, I think there is something about a circle like this on your test if I remember correctly. So there's a circle, it's centered at the origin, it passes through point P at 2, 0. Yep, I see it right here at 2, 0. The circle is dilated with a center of dilation at the origin. We're always going to do a center of dilation at the origin here in 8th grade, and a scale factor of 0.5. Oh, 0.5 is the same thing as half. My circle's going to get smaller. So, and then it's translated up 3. So 2 transformations are being done. First, a dilation. So that point P, which is at 0, 2, if I dilate it using a scale factor of a half or 0.5, it's going to become 0, 1. So I want to graph that. And then this point here, it's going to get smaller. And this point here makes the shape smaller. And this point here makes the shape smaller. So I have this circle, a smaller circle than the original one. That is my dilation of a half. But it says then translate it up 3 units. So if I take this point and go up 3, I get a new point. Take all the points, go up 3, and I see where my circle ends up. Now keep track of this point P. Here's P, so this would be like a P prime, and this would be like a P double prime. What are the coordinates of the image of point P after the transformation? So they're talking about that final result. The new coordinates I could call it P double prime, would be at 1, 3. That is the answer. At 1, 3. Number 4. This is like thoughts that you kind of have to like have in your head. We could draw a little bit. They don't have a graph for us here though. So triangle ABC is rotated 90 degrees clockwise. So I'm going to randomly draw a triangle. So hard to draw with this pen. And I'll call it A, B, C. And if I go 90 degrees clockwise is that way. It's like this triangle is now going to lay down. So this would be like my C prime. This would be my A prime and my B prime. And it then underwent a dilation with a scale factor of 4. Oh, a scale factor of 4 makes it bigger. So now this laying down triangle is going to be 4 times bigger. If I wanted to label it, I'd guess I could give it the double primes. But what parts of A prime, B prime, C prime are congruent? Yeah, I hate that they're calling it A prime, B prime, C prime. I have to tell you that. So what they're doing is they're ignoring this in-between part. They didn't label it. And this last part, they want me to just put primes on it, not double primes. So what parts of the triangle A prime, B prime, C prime are congruent to the corresponding parts of the original triangle? Explain your reasoning. So from the original to the new, the thing that stayed the same is the shape. To keep the shape the same, the angles stayed the same. So the angles are congruent. And when it says explain your reasoning, it's because the shape is the same. Definitely not the same size, though. So when I compare the perimeters, perimeter means add up the sides. The sides of the new one's so much bigger. It's 4 times bigger, so the perimeter is 4 times larger. And when it says explain your reasoning, it's because the sides are 4 times. Each side is 4 times longer. I just quickly made up some measurements for the side to prove it to you. If my original triangle had sides of 3, 4, and 5, then my resulting triangle, since each side got multiplied by 4, would be 12, 16, and 20. And this P is standing for perimeter. If I find the perimeter of the smaller one, I get 12. And if I find the perimeter of the larger one, I get 48. 48 is 4 times bigger than 12. So rectangle R undergoes a dilation, that means it changes size, with a scale factor of 0.5, which means it got smaller, and then a reflection over the y-axis. The resulting image is rectangle S. So R becomes S. Which statement about rectangle R and S is true? So right away, I know that they're not congruent because I did a dilation. So I can only say that they're similar. They can't be both congruent and similar. That's impossible. They are similar, but not congruent. I guess that's true. They're congruent, but not similar. They're neither. Nope, it's choice B. Figure 1 can be transformed to create figure 2 using a single transformation. I see it. Reflect over the y-axis. Each point is the same distance from the y-axis, just on the other side. Whenever you state the rule, that's what this is called, a rule, you have to be specific. You can't just say reflect. You have to be specific. You're reflecting over the y-axis when they ask which transformation. Which sequence of transformations? Ooh, that means more than one. A sequence of transformations takes triangle A to B. So something I'm noticing is probably I can reflect A over the y-axis and then translate it. I'd like to know if that choice is there. Reflect over the y-axis and translate. So maybe it's B. It definitely didn't rotate. It didn't turn. It flipped. It's a reverse image, not a turned image. So I betcha it is B. So let's do it. Let's reflect over the y-axis. This point is 1, 2, 3 away. Go 1, 2, 3 away. This top point is 1, 2, 3, 4, 5, 6, 7, 8. Go 1, 2, 3, 4, 5, 6, 7, 8. It's looking pretty good to me. This last point is 1, 2, 3, 4, 5, 6, 7, 8, 9. Go 1, 2, 3, 4, 5, 6, 7, 8, 9. If I connect these, it looks like it's facing the same way as triangle B. Oh my goodness, so hard to draw with this pen. So pretend that this triangle looks the right shape. I'm really having a hard time drawing with this pen, as you can see. And if I translated 2 units down, 1, 2, I could see every point would land. So it definitely is choice B. 8. If triangle ABC is rotated 90 degrees clockwise goes that way. About the origin, what will be the new coordinates? So I'm not going to do it on my transparency now since I'm doing this on the computer. So I showed you that you could also turn your paper and let the figure, see where the figure ends up when you turn your paper. So if I turn my paper 90 degrees clockwise, it's a quarter of a turn clockwise. So here I am. I could see that it ends up in the first quadrant. I'm pretending that this is my x-axis, and I'm pretending this is my y-axis. I'm pretending I'm holding my paper like normal. So if I was holding my paper like normal, I notice that A is at, ignore all these numbers, don't get confused by them because we're pretending right now. I could see that point A is 3 to the right and 2 up. That's 3, comma 2. I could see that B is 1 to the right and 4 up. That's 1, 4. And I can see that C is 1 to the right and 1 up. That would be 1, 1. So I just pretended I was holding my paper like normal. Now I will put it back to normal. And I will plot those points I just wrote down. I will plot 3, 2, and call it A prime. I'll plot 1, 4, and call it B prime. And I'll plot 1, 1, and call it C prime. And that is a 90-degree rotation clockwise about the origin. What will be the new coordinates of vertex B? B prime ends up at 1, 4. That's the answer to the question. For each pair of congruent figures, find a sequence of rigid motions that maps one figure to the other. So they're even telling us I could do a reflection first and then a translation. So if I reflect over the y-axis, I get it there. And the triangle looks like it's facing the right way now. I just have to slide it downward. How much do you slide it? 1, 2, 3, 4, 5. Followed by translation, 5 units down. So again, specifics here are important. B, you can map DFG to HJK by rotation followed by translation. So sure, if I'm going this way, it's a 90-degree rotation counterclockwise. You don't have to write down that it's counterclockwise because counterclockwise is always assumed. But when I rotate it, it's not going to land right on top of that. So again, I'm going to rotate my paper 90 degrees counterclockwise. I'm looking at this figure that I put the orange dot in because that's my original figure. I'm going to write down the coordinates. D is at -1, 2. F is at -1, 4. And G is at 1, 2, 3, 4, -5, 2. I'm going to put my paper back to normal. I'm going to plot those points that I just wrote down. Remember, you can use your transparency if you don't like all of this turning of the paper. If I plot -1, 2, it's here. That's D prime, I guess I'll call it. Negative 1, 4 is F prime. And negative 5, 2 would be G prime. If I want this triangle to land on top of HJK, looks like all I have to do is shift it up 1 unit. So I have to translate 1 unit up. Next. Again, I'm using some rigid motions, which, they're not all rigid motions actually, I can tell just from looking at part A. Rigid motions keep the same size. So since rigid motions preserve distance, there is no sequence of rigid motions that maps it. Therefore, triangle ABC is similar to triangle DEF. A dilation must have occurred. So they're not congruent, they're similar. And then B, you can map JKLM to PQRS by the translation as the following coordinates. So I just have to translate JKLM. This is my original. I have to translate it 1, 2, 3, 4, 5 to the right, and 1, 2, 3 units up. And a translation is a rigid motion, therefore they are congruent. JKLM is congruent to PQRS. Why does the fact that triangle ABC and triangle DEF have different sizes lead to the conclusion that there is no sequence of rigid motions? That's because rigid motions always create congruent figures. Since these things are different sizes, a dilation must have occurred, and a dilation is not a rigid motion, but a dilation is a transformation. Name the specific sequence of transformations that takes ABC to A double prime, B double prime, C double prime. I do notice that I should do a reflection to make the triangle face the other way. I'll call this C prime, B prime, and A prime. So now my triangle has the same orientation as my final figure. The only thing I have to do is translate. So let me write this down first. I reflect over the y-axis. And then I want to go 1 unit left and 1, 2, 3, 4 up. Translate 1 unit left and 4 units up. We're getting there. Again, I don't have a transparency, so anytime a rotation has to occur, I'm going to have to turn my paper. Perform each transformation. So translate 6 units down. This is like a typo here. and reflect over the y-axis. So O is 1 away. N prime is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And M there we go. And you do have to be able to write down the coordinates if necessary. Here they're not asking me to. Number 2, rotate PRQ 90 degrees clockwise. So clockwise goes this way. I'm going to turn my paper 1/4 turn that way. I have a class now. I will finish this later and send it to you. Okay, so now I'm on number 2 on this page. We have to rotate 90 clockwise. I had said that I have to turn my paper since I don't have transparency. Okay. And if I record these points, I see that P is at -3, 7, Q, -5, 3, and R is -6, 7. Put my paper back to normal and plot what I just wrote down. And now I take these prime figures, prime points, and reflect it over the diagonal line. So remember, you count diagonal boxes away. So R prime is half a diagonal box away, so it goes half on the other side. P is 1, 2 diagonal boxes away. So I go 1, 2 on the other side. And finally, point Q is 1 box away, so it goes 1 box on the other side. Number 3, we have to rotate 180 degrees. That means it goes like upside down. It goes 2/4 of the way around. And then we're going to do reflections. Let me do the 180 first by turning my paper 2/4 turns. Seeing where it ends up. I could see where M is. I could see where N is. 1, 2, 3, 4, 1, 2. So I'm going to try and remember what this picture looks like. If I could take like a picture of it and hold it side by side, that would be great. I'm just going to keep this in my head and graph what I just remember that I saw. I was looking at the wrong thing even. I was looking at 4. Now I see that I should have been looking at number 3, but I can still see where these points are going. I think 180 is the easiest one to do without using a transparency or turning the paper. The points just become complete opposites. Boy, so many interruptions. So now I have to reflect the new image over the x-axis. So again, when things are being flipped on top of each other, it gets a little confusing. Like this point R is 2 units away from the x-axis, so I go 2 units on the other side. And that's R double prime. Q is 1, 2, 3, 4, so I go 1, 2, 3, 4 on the other side. And S is 2 away, so I go 2 away. And here we go. That blue figure is the newest figure. This is pretty important. There's a question like this on your test. They're asking what single transformation. So that they're asking that because can you tell that this blue figure that I drew and the original gray figure really look like a reflection over the y-axis? Okay, what single transformation is equivalent to a reflection in the x-axis followed by a reflection in the y-axis? So they're just asking that question. They're not really asking us to do a transformation, but this is here so that maybe we could see it better. So reflection in the x-axis would bring M to here and N here. They switch places, but O would be over here. That's a reflection in the x, and then a reflection in the y, I'm just going to change colors, would bring N prime over here. I'll call it double prime. O prime, double prime, and M and if we take a look at my figure in orange and the original gray figure, you can see that it looks like a 180-degree rotation. So if you reflect in the x and reflect in the y, it turns out to be a 180-degree rotation. And again, there's a question asking about what single transformation is equivalent to 2 transformations. So you do the 2 transformations and then you see what single transformation would work. All right, there's one last question. Reflect triangle ABC across the vertical line parallel to the y-axis going through the point 1, 0. I'm just going to darken in my x-axis and y-axis. It's not standing out to me. So my x-axis and y-axis are in orange. The line they want me to reflect over, I'll draw in green, goes through the point 1, 0. I'm going to make it dashed. This green line is what they want me to reflect over. It is the line x equals 1. It is a vertical line. It is parallel to the y-axis. And this gray triangle has to reflect over that green line. I'm going to use black. So B is 2 units away, and I go 2 units away. This I'll call B prime. A, 1, 2, 3, 1, 2, 3, A prime, and C is 2, so I go 2. So some people let the y-axis like trick their eye. Try and just pay attention to that green line, because that was the line of reflection. So there I go. That's a reflection. I called it A prime, B prime, C prime. And then now I have to reflect triangle A prime, B prime, C prime across a horizontal line. Again, I guess I'll make it in green. And it's going to go through the point 0, -1. It's this line in green. This is really the line y equals -1. I'll change to purple. So A prime is 2 units away from that green line. I go 2 units on the other side. It's A double prime. B is also 2 units. This is now B double prime. And C is 1, 2, 3, 4, 5 units. So here is C double prime. And I called it A double prime, B double prime, and C double prime. And then finally, is there a single rigid motion? It is. It's a rotation of 180 degrees. Whenever you reflect over a horizontal line and then a vertical line, that's always equal to a rotation of 180. The tricky thing here, though, is that it's not going around the origin. It's going around the point where those two lines of reflection intersected. Rotation of 180 around the point 1, -1. And on your test, we will be going around the origin, so don't worry about going around another point. So I'm sorry for all the interruptions. People kept on coming in. I hope that this was helpful to you. And I think I did every question. I'm noticing right here on this problem that I wrote these points wrong. This is 2, 0. Therefore, this is 1, 0. Everything else is right, though. So, have a good day. Good luck on tomorrow's test. Extra help if you need it. See you. Bye.